We looked at imprinting in other segments, and in yet another segment, we looked at some problems, methodologically at least, with critical period experiments involved with imprinting. Well, here we're just going to examine briefly some problems with imprinting experiments in general. First of all, if you look at the apparatuses that people have used in laboratories to examine imprinting, here's one where a duckling has to step on a pedal to get the box to rotate and a bulb lights up in the inside. It's kind of like a visual reward for learning to step on the pedal. And in some way it's related to the bird forming an attachment to that object, but it's via an operant response, operant conditioning. It's I'm not sure if that really relates to the way that normal species identification occurs in the wild. I'm being generous by the way I'm actually wording that, and I'll have a little bit more to say about that shortly. Here's another one. This is a this is interesting. It's on a track. It's a running wheel on a track, and you can see up on top that there's a stimulus over here and a different stimulus over here. So the way this works is every time the duck takes a step toward a stimulus, it actually pulls the duck closer to the opposite one. And so what's being measured here is at what point when the duckling is over here, because it's really walking toward this one, will it turn around to try to approach this one, which of course will draw it closer to this one. It's kind of like Michael Jackson's moonwalk. Every step forward pulls you backward. Something like that. In the wild, that would make a young bird psychotic. I think if it's every step it took toward mom, it was taken away from mom. It's like, yikes, what's going on with that? Okay. It's very easy to redirect species typical preferences toward species atypical objects. In other words, normal species preferences for their own species can, in fact, via imprinting experiments, be redirected toward junk objects, like this duckling that's formed an attachment to this weird mask, or these kittens that have imprinted on this chicken, and the chicken, I guess, is more than happy to take care of the of the kittens. So, I guess things like this happen in the lab. It's very easy to make that happen. In the wild, sometimes things happen by accident. Basically, I'm talking about a broader category of issues here. It's, for lack of a better term, what I call can versus does research type questions. They're both legitimate, but I think it's important to keep them distinct. So you can ask a can question. Can an organism learn by operant conditioning, for example? Or can you get it to redirect a species typical preference toward a species atypical object? Basically, when you're asking that kind of a question, you're looking at plasticity, or what an animal is capable of, how malleable it is, how can you get it to do things it otherwise might not do. And that's fine. It's really interesting to study plasticity. But it's really important, I think, to keep that distinct from the actual does type questions. Do animals learn things by operant conditioning on a daily basis in the real world? Do animals typically redirect species typical preferences toward species atypical objects as they are engaging in species identification type issues, whether it be in the filial area, in other words, early in life, or later on when they're looking with who they're going to mate with? It's a very different type of questions. What do organisms typically do, as opposed to what can you get them to do? So, all I'm saying here, it's fine to ask a can question, but don't think that necessarily what you're learning from doing that necessarily applies to the does problem of what organisms typically do. It may, but it may not. And so you really have to look further to see whether or not it generalizes to what organisms really do. Having said that, there are these situations that occur from time to time. They're unusual, but sometimes misimprinting in the real world can occur.
It was a very lucky coincidence for the ducklings that the cat found them just after giving birth herself. For a narrow window of a couple of hours, mothering hormones will have been coursing through her body, causing her to love and nurture any small, warm, furry creature she found next to her. Several weeks later, the kittens are still small, and the ducks, although independent, still have an attachment to their surrogate mum. So it would seem that this rare coincidence of a cat giving birth just as the ducklings were making their first steps into the world resulted in this remarkable situation. Filled with an instinct to mother small furry creatures, the cat ignored any natural urge to eat the ducklings and took them on as her own.
Even though they're not furry, they're, well, early in life, they're downy, covered with down, and then they become feathery, not furry. You know, I'm thinking about what would happen with those ducks when it comes time to choose who they're going to mate with, if they're going to create some kind of weird hybrid like that, but I think not. But, you know, in the wild, things do happen. Sometimes broods of birds mix on a pond. You'll have different species kind of intermixing, and then for whatever reason, a duckling or two might get separated from its own mom and accidentally start following another, and then suddenly can't find its own mom or broodmates anymore, so it just stays with the other mother, assuming the other mother will tolerate it. And so here's a situation with what is now an adult male wood duck that somehow at an earlier age got raised by mallards, because it is just leading these mallards around. And it's even driving off actively rival males, even though a mallard is not a rival male in terms of mating for a wood duck. But so I guess as far as this wood duck concerned, he thought he was a mallard. Here's another situation involving a goldeneye. That's a goldeneye duckling that has taken up residence with this female mallard and her brood. So following that mallard around like mom, again, it probably got separated from its goldeneye brood by accident. And now here it is as an adult. It's still a duckling there. We'll see it as an adult in a moment. So there it is as an adult, and it is now courting mallard females, even though other goldeneyes are available. So as far as it's concerned, it's a male mallard. In conservation programs, humans have to be really careful to prevent this kind of thing from happening, because it's humans that are feeding animals, and these are often endangered animals, or sometimes they're just injured animals that are being cared for and fed in captivity until they can be effectively released into the wild. You don't want them imprinting on humans, because when they're turned loose, you want them mating with another member of their own species. And not, well, first of all, they're not going to mate with a human, but they won't be ignoring members of their own species. So people will often take puppets and feed the young chicks with these puppets so that they learn about what their own species as an adult looks like. And here's a guy that is just totally getting rid of the human shape altogether when feeding this bird by draping this basic sheet type thing over himself that sort of hides the fact that there's even a human configuration there. And again, these are cranes that were endangered and or injured. I'm not sure how these guys got here, but again, they're being fed by a human who's hiding his face, wearing this puppet.
And this is surely one of the most extraordinary hand-rearing devices yet invented. A whooping crane adult hand glove puppet with a trigger inside so that I can operate the beak. I'm speaking quietly because behind each one of these doors there is a whooping crane chick, and it's very important that they don't get used to the sound of human voices at this early stage in their lives. It's even more important, of course, that they don't see human beings, which is why they're fed with this glove puppet. Here at the International Crane Foundation in Wisconsin, they believe that were the chicks to be fed by humans directly and visibly, they would risk becoming humanized, so that when they became adult they wouldn't be able to breed with their own kind.
So yeah, this is a way of circumventing the problem of misimprinting. And again, we see it here. Now, these guys are actually mimicking feeding movements that these adults would make as they're trying to direct their offspring to sources of food. Now, these guys are still young. They're not adults yet. So they're still going to be relying somewhat on being shown food sources. So that's exactly what's going on there. Okay, so important to make sure misimprinting doesn't happen, and of course it's rare that you have these cases of broods intermixing and things like that where one of the ducklings gets taken up by another brood. But as you saw, it does happen, and basically, though, those are the exceptions to the rule. Again, it's important to keep can and does questions distinct. And when you look at a lot of the methodological means by which people have looked at studying imprinting in the lab, especially starting around the 1950s. Oh my gosh, there were tons of experiments. There's some really unusual things and procedures that people have used in terms of the kinds of stimuli they have chosen to imprint to and the manner in which they've gone about imprinting the animals methodologically.